quick problem. You have 454 grams of helium, that's a pound, helium in a rigid 200-liter container at 25 degrees Celsius. First question is, what's the pressure in the container? And to solve this, you could just do PV equals nRT. I put subscripts here for, P, the pressure of helium, and the number of moles of helium, just to remind you, these two things are linked, right? The volume of the container is the container, so whatever gases are there, that will be the volume. The temperature is what the temperature is. If you had multiple gases in the container, the temperature is going to be the same for all of them. If you have multiple gases in the container, the volume is going to be the same for all of them. However, if you have multiple gases, the number of moles will be per substance, and the pressure will be kind of per substance. So you don't need to do this to solve this first problem, but I just wanted to highlight it. So we've got pressure is nRT over V, and we convert 454 grams to moles by dividing by the molar mass. R, there's T, divided by 200, and you get 13.9 atmospheres. Okay, so then we take 450 grams of argon and put them in the same container. It told you that the container was a rigid container. You should get used to that with gases, because it just means that the volume's not going to change even if the pressure increases, right? Other containers might expand or shrink. We get 454 grams of argon are added, and we heat it to 100 degrees Celsius. What is the new pressure in the container? Just a reminder, it's at 25 degrees Celsius. I converted that to 298 Kelvin. Make sure to add 273.15 to get Kelvin. So we've got 100 degrees Celsius, so our new temperature is 373 Kelvin. New pressure in the container. For number 2, I wrote, figure out how many moles of gas. If you want the pressure in a container, the total pressure in a container, you need the total number of moles of gas. So it's 113 moles of helium, and 450 grams of argon is 11.26 moles of argon. I'm going to use a rearranged ideal gas law, so PV1 over NT1 equals PV2 over NT2. I'm using this because oftentimes in problems, I made a little note here, oftentimes in problems it'll just say that the volume remains constant, or it'll say the pressure remains constant. So you don't have all of these oftentimes, right? If you don't have every one of these 4 variables, or 3 out of the 4 variables, you can't calculate the 4th using PV equals nRT. But we can always compare, even though some things are held constant. So many problems have that, especially if you see that it's a rigid container. So here's what we know. We know it's constant volume, so we're not worried about V. We have initial pressure, initial temperature, and initial number of moles. The 113 moles was just for helium. We're looking for P2. We have the second temperature. Temperature went up. We expect the pressure to go up. The number of moles went up. We expect the pressure to go up from that too. So we start with this equality. It's kind of a combined gas law with number of moles here too. And I'm getting rid of volume to make it easier to look at. Volume's constant, so, and then we rearrange. We get P2 with that. Plug in your values, and we get 19.1 atmospheres for the P2.